has a project of SpaceBase is our company that we just founded in New Zealand to encourage space activity, entrepreneurial space activity in New Zealand. And one of our first projects is partnering with Christchurch NZ to run this New Zealand Space Challenge. And so I'll jump right in and talk about the challenge. What we wanted to do was create a challenge that would apply to long-range future missions in space, but have some practical benefit right now. And so one thing that Christchurch is known for around the world is Antarctic operations. They're the base for U.S. All U.S. Antarctic missions start from Christchurch, and logistics, and they support the New Zealand Scott base, and so it's been 60 years of New Zealand expertise in Antarctica, and I think it's a great foundation for future space activities on the Moon and Mars are directly analogous to what's going on in Antarctica. But Antarctica has its own challenges, which is crossing the ice and not falling into these crevasses. And this is from the 1959 Trans-Antarctic expedition from the UK and New Zealand, back when Sir Edmund Hillary crossed and went to the South Pole. And somehow they say that they got this vehicle off the crevasse somehow. I don't know how, but yeah, but they also had another vehicle that plunged down, and that was the first New Zealander to die in Antarctica. I like this image because it was also chosen to represent exploration and the challenges, and was put on the Voyager spacecraft, and it's going outside the solar system right now. So basically, there's traversing Antarctica. This is our friend Dan Price recently conducted this traverse of the Ross Ice Shelf. It took him 6 weeks to go several thousand kilometers, and the idea is that you need to go out to this area to drill through the ice and detect what's going on underneath the ice, because it's so important for the climate evolution of what has happened in the past and what will happen in the future with all this massive ice sheet. And so this is the how we've defined the challenge, which is using new or current technologies or data in space or on the ice, find the best methods to identify hazards and map a path across the ice, and or design and prototype new sensor systems and algorithms to help vehicles navigate across the ice in Antarctica. So part B is more about sensors on the vehicle, like detecting crevasses and things like that. But part A is using spatial data from remote sensing satellites and finding a path across the ice, and that's where we think QGIS could be an important part of this as a foundation for analyzing the data. But in some ways, the challenge is also just an excuse to get people to learn the power of QGIS, and because it applies to so many different areas. So we see the satellite data analysis as one element that addresses the challenge and helps generally in extreme environments in all sorts of different areas. It has application for future space applications, and then also has lots of routine or regular commercial applications. And this is an example. The resolution is not good, but this was some of the planning that went into their traverse that Dan was on. Here's from the satellite data, mainly synthetic aperture radar data of the ice. There was a sort of a manual labeling of where the crevasses were, and this is the kind of data that they had, and you can see that this is the path they ended up taking where they go 50 kilometers out of their way just to avoid certain crevasse fields here. And they have to thread their way through the crevasses while sensing continuously to make sure they don't drive into one. And yeah, this is that hand-drawn diagram, and this is that close-up on the. But you can see that if they're coming from here, they didn't just cut across all these areas because they could identify the crevasse fields there. And this is to show an example of what kind of that they had lots of optical and other kinds of data and in-civic aperture radar data. But this is the kind of problem that you have with crevasses, is that even if there's a hole that plunges down, if you're lucky, the snow may slump in a little bit, and with a visual image, you might see lines like this. But oftentimes, the snow is just completely covered up the gaps in the ice. But with synthetic aperture radar data of the same area, you can start to see the crevasse fields. And so, and this is the kind of thing where this is a Greenland example where they're driving a small rover back and forth to detect the crevasses. But you can see that they got an early indication of certain areas, and then they're trying to thread their way through and measure find the gaps in the ice. So just the combination of this SAR data with very subtle indications of crevasses, it's sort of like an even more challenging exploration of the QGIS system, because with the I think you'll be training us with data that is more obvious in terms of terrain differences and things like that. This is a very subtle kind of, and it's also an extra complication is on the Ross ice shelf. The ice moves a meter or two every day, and so what you think is a location may not be the same location when you come back to it. They have difficulties with aircraft trying to land on runways, and find the runway has moved since it was last measured.
Oh, yeah, we work on that a lot.
Yeah. But we have a lot of partners supporting us in this challenge that is going on. The deadline for the submissions for the ideas is April 30th, and the final there'll be a regional finalist, and then the regional finalists will present and have a winner on May 24th in Christchurch. I think that's